Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we'll support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Teaching you live in daily lectures along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join Plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter Plus, every need of yours will be taken care of and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture. And if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys. Up to now I have been talking to you about linear applications of Opamp in which we were using the concept of virtual ground and we were finding the gain of the amplifier under different configuration. We have seen multiple configurations such as inverting amplifier, non-inverting amplifier, differential amplifier, integrator, differentiator, all such sort of application. In this video what we'll do is we'll talk about the non-linear applications. That is where the output is not directly proportional to the input, or you can say we are using some sort of non-linear devices, either BJT or diode. So we'll deal with such circuit where Opamp is not the only electronic device in the circuit, but there are other devices such as your diode or BJT. Okay, so this topic will be very interesting because now you will get to understand how do we use the concepts that we have learned so far with Opamp. Okay, so let us not waste our time. Starting with the first device. The first device is called as comparator. As you can see the circuit on your screen, you will be observing that there is no closed loop. Okay, so this is nothing but it is an open loop configuration. Okay, in open loop configuration, earlier we were calling it as a differential amplifier, right? When we studied open loop configuration, we were calling it as differential amplifier. So this is nothing but a differential amplifier. Okay, in that case what we know is V0 is equal to A times, A is the open loop gain, positive terminal voltage minus negative terminal voltage. Now we very well know that A is high. If A is high, then V0 will be high. If V0 is high, you can understand that Opamp will saturate. Why Opamp will saturate? Because we know one thing, that output voltage can never exceed the supply voltage, and the supply voltage in this case has been written as plus Vsat and minus Vsat. So now what I will say is this value will become equal to A. What is the positive terminal voltage? V into minus V in 1. Now take two cases. Case 1. If the input voltage at positive terminal is greater than the input voltage at negative terminal, in that case what will happen? The positive terminal voltage is higher, so V0 will be equal to Vsat. Okay. And what will happen in the second case? If I talk about case 2, if V in 1 is more than V in 2, that is the negative terminal voltage is more than the positive terminal voltage. In that case V0 will be minus Vsat. That means the output can have two possible values, either plus Vsat or either minus Vsat. So by observing the output, you can always tell which input voltage is greater, either the positive input voltage or the negative input voltage. So by observing the polarity of output, we can tell about which voltage is higher and which voltage is lower. And this process is basically called as comparison, and hence this device is called as comparator. Now what I will do is, I'll take an example of a waveform and I'll show you how you can understand. Okay, so let me remove all this. This basic thing is clear. If positive terminal voltage is higher, the output will be Vsat. If negative terminal voltage is higher, the output will be minus Vsat. Now let me assume that the input voltage of positive terminal is constant, let us say 2 volt, whereas V in 1 is a triangular wave. So let us see what will happen. So I'll have to draw two waveforms. First I am drawing the input voltage at terminal 1, V in 1. Suppose it is a triangular wave. So let me take triangular wave like this. Okay. Now what will happen is, suppose the input voltage at 1 is 2 volt. Okay. So this is 2 volt. Suppose it has a peak value of 4 volt. Now what I will say is, when I want to draw the output, I will have to check the points of intersection. Okay, like this. So I will say when the input voltage at terminal 1, this is V in 1, it is lesser, that is V in 2 is higher, the output will be plus V set, and when V in 1 is higher, the output will be minus V set. So that way the output will oscillate between plus V set and minus V set. Okay. So based on a triangle wave, what I have generated here? I have generated a square wave. Is it fine? So what you have to remember in comparator, simply it is a differential amplifier in open loop configuration. If positive terminal voltage is higher, then it will be plus V set, output will be plus V set. If negative terminal voltage is higher, output will be minus V set. And the application of such a device is coming in ADC, or you can say analog to digital converter. Okay. Next device. So first let me summarize the comparator, then I'll go on the next device. What you need to remember, if V positive is greater than V negative, V naught will be V set. If V positive is less than V negative, V naught will be minus V set. Okay. Only this much if you remember, it will be sufficient for the case of comparator, and assumption is, assume open loop gain is very high. Why I am assuming open loop gain is high? Because even the smallest difference in the two inputs will lead to saturation of the op-amp. So even if you change the input slightly, that is if there is a small difference between V in 1 and V in 2, the output will saturate. Moving to the next device, the next device is called as precision diode. Now when we talk about a practical diode, what happens in a diode? A diode basically conducts in one direction, that is from anode to cathode, and if you apply the reverse voltage, the diode does not conduct. It is a very simple device. If you apply a positive voltage or forward biasing, it will conduct. If you apply reverse biasing, it will not conduct. Okay. So now what happens in a precision diode? When we talk about a practical diode, it has a voltage drop of V gamma, which we call as the knee voltage or the cut-in voltage. Okay. But when we talk about precision diode, that is diode with an op-amp, in that case the cut-in voltage is almost zero. So that means it will behave like an ideal diode. Think about it. In an ideal diode, what is the cut-in voltage? It is 0. In a practical diode, in silicon it is 0.7. In germanium it is 0.3. So what I want to do is, I want to realize an ideal diode but using a practical diode. How to do that? Now how did I tell you to simplify any circuit involving diode? We will apply either open circuit or short circuit test. So I am using open circuit test. Why so? Because we never know the output current of op-amp. So it is always better to use open circuit test when we are talking about op-amp circuits. Okay, minus plus. So this is open circuited. Okay. Now due to open circuiting the diode, there is no closed loop. That means it is a open loop op-amp. If it is a open loop op-amp, let us see what will happen. There is no path of current flow. So in open circuit test, you can say V naught will be 0. This voltage will be 0. Okay. Now, if this voltage is 0, the voltage of negative terminal is also 0. Okay. But what is the positive terminal voltage? It is Vs. Now there can be two cases. Case 1, Vs is greater than 0. In that case, positive terminal voltage will become greater than negative terminal voltage. If that thing happens, this voltage V, it is the open loop configuration. Remember the previous case, comparator. When positive terminal voltage is greater than negative, V is equal to V set. Okay. Now see the diode voltage. What is the voltage across diode? It is V minus V naught. V naught is 0. It is V set. So diode will be on. Okay. What about case number 2? Case number 2, when Vs is less than 0. Now positive terminal voltage is Vs, negative terminal voltage is 0. So positive terminal voltage is less than negative terminal voltage. In that case, V will be equal to minus V set. Okay. So the diode voltage, which is V minus V naught, will be minus V set. The diode voltage is negative, so diode will be off. So what I have observed, that this circuit is behaving like a diode, that is, for positive input the diode is on, and for negative input the diode is off. Now when diode will be on, what will happen? You will replace the diode by its cut-in voltage V gamma. Okay. So you will replace it by V gamma. Now what will happen? Let me tell you when diode will be on. Okay. Let us see why I told you earlier that the cut-in voltage will be 0. So what we can say is V equal to A times Vs minus V naught. Why? Because the voltage here is V naught. Okay. So what I am applying here is the short circuit test. I am assuming diode to be on. So V is A Vs minus V naught. Now V can also be written as V naught plus V gamma. That is, I am applying KVL. The voltage at this node is V naught plus V gamma. So AVS minus V gamma equal to V naught 1 plus A. So what is V naught? A over 1 plus A Vs minus V gamma over 1 plus A. Now if the open loop gain A is very high, this term will tend to 0 and V naught will become equal to Vs. For high value of gain, this diode will not offer any voltage drop. The output will be equal to Vs, and that is the beauty of precision diode. That is, when diode is on, the output follows the input voltage and there is no voltage drop. In a practical diode, we saw that there is a voltage drop of 0.7 volt or 0.3 volt. But in case of precision diode, the V naught is equal to Vs. So what I can say is, when I will draw the characteristics, which characteristics? Transfer characteristics, V naught versus Vs. If Vs is positive, the diode is on and V naught is equal to Vs. So this straight line will have slope equal to 1. And when Vs is negative, the output is 0. Okay. So it is kind of a half wave rectifier. Okay. Because in positive cycle, it is giving output same as input, and in negative cycle, the output is coming out to be 0. So if you take the graph against time, suppose I want to draw Vs versus t. So I am taking Vs as a sinusoidal source like this. Okay. Now, if I talk about V naught, what I have seen up to now, in positive cycle, V naught is same as the supply voltage, but in negative cycle, V naught is 0. So here it is same as supply voltage, and in negative cycle it is 0. Then same as supply voltage. Okay. So what is the advantage here? That with the help of an op-amp, we have realized an ideal diode, and in that case the cut-in voltage has become 0. That is, if you apply positive voltage, diode will be on. If you apply negative voltage, diode will be off. There is no criteria of knee voltage or cut-in voltage V gamma. So we have realized an ideal diode. But what happens, see, when diode was off, what was the voltage across the diode? Minus Vsat. So that will be called as the peak inverse voltage. That is the maximum negative voltage is Vsat. It is very high. And this high voltage can lead to breakdown. If you don't want the device to break down, what you have to do? You have to buy a diode which has higher breakdown voltage, and if you do that, then your cost will also increase. So what I have said is, at such a high voltage the diode can get damaged, and if you want to protect the diode, you have to choose a diode which has a higher voltage rating, and that will increase your cost. So what is the advantage of precision diode? That we are realizing an ideal diode. What is the drawback? That the diode has higher value of peak inverse voltage, which can lead to increase in cost or breakdown. Okay. So let us move on. Next application of non-linear application of op-amp is called as your half wave rectifier. Now let us study the circuit first. We have an input voltage connected at the inverting terminal. We have the positive terminal connected to ground. So what I can say, V plus is equal to 0. Then we have two diodes D1 and D2 and three resistances R1, R2 and RL. Now this circuit at first seems very complicated. Let me simplify it for you. I will go by the basic method. I will apply open circuit test. Okay. In that case, what I will do is, I will open circuit both the diodes. Okay. Now there is no purpose of using RL. You can also avoid that in the circuit. Just show V0. Okay. So even if you don't show RL, it is fine. This is R2, R1 and Vi. Now see one thing, that there is no closed path for current flow. Also you can observe one thing, that there is no feedback, because for feedback the output terminal must be connected to input, but there is no such connection. If there is no feedback, there is no concept of virtual ground. So there is no virtual ground and current is also 0. In that case, the negative terminal voltage, if current is 0, there is no voltage drop across R1. You can say V negative is Vi. What about V positive? It is 0. So there are two cases. Case 1, if Vi is greater than 0. If Vi is greater than 0, then let me call this voltage as V. In that case, the negative terminal voltage is greater than positive terminal voltage. If negative terminal voltage is higher, V will be equal to minus Vsat. Okay. So what is the voltage across D2? The voltage across D2, this terminal is Vi because due to 0 voltage drop. The negative terminal is connected to minus Vsat. So Vi minus Vsat. So Vi plus Vsat. Okay. What about VD1? The positive terminal voltage is V and V0 is 0 because there is 0 current flow. So it is minus V set. This value is positive whereas this value is negative. So you can say D2 is on and D1 is off. So we have found out the states of diode when Vi is greater than 0. Let me take the opposite case. So I'll go for case number 2, that is when Vi is less than 0. In that case, the negative terminal voltage is less than positive terminal voltage, or you can say V is minus V set. Okay, the value V will be minus V set. Okay, this much is fine. In that case, if we see the previous circuit, okay, if we see the previous circuit, what will be the value of VD2? VD2 will be Vi minus V, or you can say, sorry, this will be plus V set, Vi minus V set. This value will be negative. What about VD1? V minus 0, or you can say V set. That will be positive. So you can say D2 is off whereas D1 is on. Now in order to observe the output, let me take case 1. If you say, so D2 is off and D1 is on, in the previous case D2 was on and D1 was off. So in case 1, D2 was on and D1 was off. So see, in this case, the current cannot reach V0. If the current cannot reach V0, V0 will be 0. See, first of all, there is negative feedback. If there is negative feedback, then we can apply virtual ground. This is 0 volt. This will also be 0 volt. So V0 will also come out to be 0. Then there is case number 2. In case number 2, we are experiencing the opposite case. What opposite case? That D2 is off whereas D1 is on. Okay. If such a thing is happening, this is Vi, R1, R2. Now you can easily see that this is an inverting amplifier. This is the feedback path. If it is an inverting amplifier, V0 is Vi minus R2 by R1. Since Vi is negative and it is being multiplied with a minus sign, V0 will be positive. So when Vi is greater than 0, V0 is 0. When Vi is less than 0, V0 is positive. So how you can explain the transfer characteristics of such a circuit? If you plot a curve between V0 and Vi, what we have seen? When Vi is positive, V0 is 0. So it is 0. When Vi is negative, V0 is positive. And the slope is minus R2 by R1. Also, you can draw the waveform against time. Okay. So first let me take a sinusoidal waveform for Vi like this. What about V0? When Vi is positive, V0 is 0 in positive half cycle. But when Vi is negative, V0 will be positive, and it will be, if this value is minus Vm, it will be multiplied by R2 by R1 also, Vm R2 by R1. So basically it is rectifying the negative cycle of the input and not rectifying the positive cycle. So that is why it is only a half wave rectifier. If you reverse the orientation of diodes, if you reverse the terminals of D1 and D2, then it will rectify the positive cycle and it will not rectify the negative cycle. Okay, that is, if you want it to rectify the positive cycle and remain 0 in the negative cycle, you have to reverse the orientation of diodes. Now let me summarize what we have covered in this video. First of all, I have told you about the first application, that is comparator. In comparator, we say if positive terminal voltage is greater than negative, V0 is Vset. If positive terminal voltage is less than negative, V0 is minus Vset. Then we have seen the second circuit, precision diode. In this case, we saw that V gamma diode was becoming V gamma over 1 plus A, which is almost 0. Okay, so that is why it has 0 cut-in voltage, but in this case PIV was Vset. And the last circuit we saw was half wave rectifier. Okay, in this I told you how to analyze the circuit using open circuit test. So you can always analyze any circuit involving op-amp and diode using open circuit test and determine the state of the diode to find the output. So this is about the non-linear applications. We'll see some other non-linear application like full wave rectifier, peak detector. All these things we will cover in the next video. Okay, so this is all for this video. Thank you.
For 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250. With code Ankit ESE, it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JEE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these 2 channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.